Hi there. Hope everyone's doing well. We are going to talk today about solving systems of equations. And now that we have all of our different methods to solve, we're going to talk about how do we know which way is the best method to use in which situation. So our methods that we've learned are graphing, substitution, and elimination. All right. So graphing, we've talked a lot about, is awesome. And the whole idea of solving a system of equations is that you're looking for, if you were to graph, where would the point of intersection be? But we talked about the limitations with graphing. Sometimes our intersection point is going to be at a decimal or a fraction. And then sometimes it might be at a point like 100 comma negative 27, and you don't want to graph all the way out that far. So graphing is always kind of our last resort. And you really only want to graph if you're specifically asked to graph. So let's talk about the difference between elimination and substitution. So I would use elimination when I have my two equations in standard form. In other words, like ax plus by equals c. So if my equations are in standard form, ax plus by equals c, that's when I'm going to use elimination. Remember, elimination is when you're going to add the two equations together and you want two of your coefficients to be opposite values so that they cancel out, right? So for example, here's just a for example. If I have like 2x plus 5y equals negative 10, and then if I have like 3x minus 3y equals 7, both of those equations are in standard form. If I add them together as is, nothing's going to cancel, but I can pretty easily multiply each equation by a value to get opposites and to get something to cancel out. Okay, so that's elimination. Substitution, on the other hand, I'm going to use substitution when I already have one variable by itself. So the equations don't necessarily need to be in y equals mx plus b. Y could be by itself or x could be by itself. It doesn't matter. But here's a quick example. If one of my equations is like 5y equals 3x minus 2, and the other one is like x is equal to negative 2y plus 7, something like that. See how this x is already by itself? Because that x is already by itself, I can pretty easily take this and plug it in for x in the other equation. That's the process of substitution. All right. So let's do some quick practice problems. Oh, there we go. All right. So number 1, solve the system by graphing. So y is equal to x plus 2 and x is equal to negative 3. So I'm specifically telling you now that I want you to graph. So you want your equations to be in y equals mx plus b form, all right? So this first equation here, y is equal to x, there's an invisible 1 in front of there, right? So we know our slope is 1, and we know our y-intercept is going to be the point 0, 2. So in order to graph, I'm going to put a point at the point 0, 2, and I'm going to use the slope. I need the slope to be a fraction. It's not a fraction. It was a whole number. So anytime it's a whole number, I can put it over 1 to make it into a fraction. And this tells me to go up 1 over 1, put a point. Count up 1 over 1, put a point. Up 1 over 1, right? That's positive 1. But I could also go down 1 and to the left, because down's negative, to the left's negative. And a negative over a negative is a positive. So if I can keep going down and to the left, that gives me a positive slope as well. When I connect them and draw arrows, that's that first line. And then I have x is equal to -3. So here's the thing. I don't have a y. I can't get y by itself. I can't solve for y. I can't put it in y equals mx plus b form. But if we have x equals 3, that means that this line is only going to go through the x-axis. So it's going to be a vertical line. Remember, we talked about the slope being undefined. So I'm going to find -3 on the x-axis. Here's -3. And my line is going to go like that. It's going to be a vertical line. So to solve the system, I'm looking for the point that these intersect at. And this is the point -3, -1. So there you go. All right, number 2. So these equations are not in y equals mx plus b, but here's the thing. I told you specifically you need to solve by graphing. So we need to graph, we need to put them into y equals mx plus b form. So I'm just going to rewrite the top equation, and I'm going to solve for y. I'm going to get y by itself. In order to do that, I need to get rid of this 4x. I'm going to subtract 4x from both sides. I have y is equal to -4x plus 2. My slope is -4. My y-intercept, 0, 2. And my slope has to be a fraction, so I can put that over 1. So if I start at the point 0, 2, that's this point right here. And my slope is -4, so I got to go down 1, 2, 3, 4. But then over +1, right? It has to be -4 over 1. And then I go down 1, 2, 3, 4. I'm actually off the grid here, but it would be kind of there. On the other hand, I could go up 1, 2, 3, 4, and over 1. That's also off the grid. But then I can connect these points. There you go. Now my next equation, x minus y equals 3. Again, it's not in y equals mx plus b form. I need to put it there. So I need to get rid of the x. I'm going to subtract x from both sides. I have negative, oh goodness. I have negative y is equal to -x plus 3. Don't forget about that negative. And y is still not by itself. So I have to divide both sides. I have to divide, oh my goodness, sorry. I have to divide both sides by -1, -1, -1. And so I'm going to get y is equal to +1x minus 3. So from here, my slope is 1. The number in front of the x, there's an invisible 1. Make it into a fraction. And my y-intercept is going to be the point 0, -3. So point at the y-intercept, my slope goes up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. You could also go down and to the left because a negative over negative is a positive, right? Connect them, there's your line. And again, I'm looking for where these two lines intersect. That happens at that point right there that I just circled. And that's the point 1, -2. So there's my solution there. All right, so that was your quick review of graphing. But now, if I tell you to solve the system by any method, you have to think about what's going to be better, graphing or not graphing, either substitution or elimination. And remember, we're going to use substitution if one variable is by itself. If your equations are in ax plus by equals c, you're going to be better off using elimination. So let me look at number 3. I noticed in number 3 that y is by itself. Actually, y is by itself in both equations. But I'm just going to start with the top equation. So in the top equation, y is equal to 4x minus 9. So that whole thing, 4x minus 9, can go in for y in the other equation. So in the other equation, I'm plugging in 4x minus 9 for y equals, and then I keep the rest of the equation the same, x minus 3. Remember substitution? And now here's the thing. That parentheses over on the left-hand side, I don't have anything to distribute or anything, so I can just kind of like drop it. So 4x minus 9 equals x minus 3. I'm just recopying basically the same problem without the parentheses. And now I'm going to solve. I want to get x by itself. I need to get the x's together on one side of the equation. To do that, I'm going to subtract x. I have 3x minus 9 equals negative 3. And then to get x by itself, I'm going to add 9. I have 3x is equal to 6. Divide by 3, x is equal to 2. Now that I know that x is equal to 2, I can pick either one of the original equations to plug in. I'm just going to pick the top one. Y is equal to 4, and then instead of x, I'm plugging in a 2. So I have y is equal to 4 times 2 minus 9. I got to multiply. 4 times 2 is 8. 8 minus 9 is negative 1. But now here's the thing. I always write my answer, my final solution, as a point. In parentheses, this is the point 2 comma negative 1. And remember, the significance of that point is that this is where the two lines would intersect if I were to graph them. All right, so that was number 3. Let's look at number 4. If I look at number 4, think to yourself, are these equations both in standard form, ax plus by equals c, or do I have one variable by itself? So to me, it looks like they're both in standard form, right? Ax plus by equals c. Elimination is going to be easier most of the time when that's the case. So elimination, if I add these two equations as is together, nothing's going to cancel. You know, the x terms aren't going to cancel, the y terms aren't going to cancel. So I can't just add. I got to force something to cancel. I notice that if I take this bottom equation and multiply it by 2, the x term is going to be negative 4x, right? And negative 4x and this positive 4x up here can then cancel out. So let me just multiply this whole equation. So plus 4y equals 12. And now I'm just going to rewrite the top equation just so they're right on top of each other, just to make it easier when I add them together. So now I'm going to add the two equations together, 4x minus 4x. Those are opposite terms. They cancel out. Now I have 3y plus 4y, so I have 7y equals negative 5 plus 12 is 7. Divide both sides by 7, I get y is equal to 1. And now I can pick either the top or bottom equation, does not matter which one. And instead of the y, I'm going to use the top equation. Instead of y, I'm plugging in 1 for y equals negative 5. And now I'm just solving for x. So 3 times 1 is 3. Get x by itself. I'm going to subtract 3. 4x is equal to negative 8. And then x is equal to negative 2. So my final answer is the point negative 2, comma 1. And again, I have to write it as a point because the significance is that this is the point where these two lines would intersect at, right? If I were to graph them. All right, so now that we did a couple problems together, I want you to try some on your own. So here's 5 and 6. So you can pause the video at this point and I want you to try this problem. So number 5, I would probably use elimination to do this, right? Because these are both in standard form, ax plus by equals c. So if I were you, I would use elimination. And you're going to go through that process, but your answer, just so you can check it, should be this. All right, pause the video one more time, and then you can try number 6. So think about what method you would use. So I noticed that x is by itself here, so I would probably use substitution. And this ends up giving you a really ugly answer. But that's going to be your answer, your final solution. All right, guys, that is all I have for you. Thank you so much for watching. I hope that you have a great day.